This is the 2019 MEXT Special Training College Mathematics paper. Section 1, Number 1. We have an inequality with an absolute value. So let's first of all try to visualize what is happening in this question. 4x is a linear equation that goes through the origin, and the absolute value of x plus 3 is going to look like this. So the y-intercept is at 0, 3, and its slope is 1. And because the absolute value implies that this graph cannot be below 0, it's going to bounce off like this. And the inequality sign here says that 4x has to be above x plus 3. So we are talking about this region here. So we basically have to find the intersection here, which means that we are only concerned with the positive version of x plus 3. So the x-coordinate of the intersection here is 1, and for 4x to be above the graph of x plus 3, the x value has to be greater than 1. So this is the answer. Section 1, Number 2. So in this question, we have an equation x plus y plus z equals 4, and we are told that x, y, and z are either 0 or positive integers. So we are basically permutating these 5 numbers. So if one of these 3 variables is 4, then that implies that the other 2 are 0, and there are 3 permutations. Secondly, if one of these variables is 3, then the rest must be 1 and 0, and there are 6 permutations. Third, if one of the variables is 2, then the remaining 2 numbers must be either 1, 1 or 2, 0. So there are 3 permutations, another 3 permutations. And since there are no other possible combinations, we only need to add these numbers up. So the answer is 15. Section 1, Number 3. So in this question we have 2 points, O and A, and OA is the diameter of this circle, and we need to find the equation of this circle. So let's first of all define the center of the circle as B, and the coordinates of the center must be 3, 4. So based on this information, we know that the equation looks like this: x minus 3 squared plus y minus 4 squared. And then we need to find the radius r. The length OC is 3 and the length BC is 4. So let's use the Pythagorean theorem to figure out the length of r, or OB. So this is the final answer. Section 1, Number 4. So in this question, we need to express log base 4 of 9 as log base 2 of something, and then log base 9 of 4 as log base 3 of something. And then we need to evaluate this expression here. So let's start with log base 4 of 9. So we're going to use the change of base rule, which says the following: the new base c can be arbitrary. Since this question requires the new base to be 2, we're going to pick 2. Nine is 3 squared. And remember that the exponent 2 can be brought to the front. So log base 2 of 9 is 2 times log base 2 of 3. And likewise, 4 is 2 squared. Log base 2 of 4 is 2 log base 2 of 2. Log base a of a is 1. So this is 1, and these two will cancel out, and we are left with log base 2 of 3. Next, let's work with log base 9 of 4. And using the same rule, let's choose 3 as the new base. Once again, 9 is 3 squared. So log base 3 of 9 is log base 3 of 3 squared, which is 2 log base 3 of 3. This part becomes 1, so this is equal to 2. And once again, 4 is 2 squared. So log base 3 of 4 is 2 log base 3 of 2. So log base 9 of 4 is log base 3 of 2. So next, let's replace log base 4 of 9 with log base 2 of 3. And let's also replace log base 9 of 4 by log base 3 of 2. And we get now log base a of b times log base b of a equals 1. So the answer is 4. Section 1, number 5. In this question, we have the sixth root of 25 times the cubic root of 25 divided by the square root of 5. The sixth root of 25 is 25 raised to the power of 1 over 6. Likewise, the cubic root of 25 is 25 raised to the power of 1/3. The square root of 5 is 5 raised to the power of 1/2. 25 is 5 squared, so this becomes 5 raised to the power of 2/6, which is 5 raised to the power of 1/3. And this becomes 5 raised to the power of 2/3. 5 raised to the power of minus 1/2. And we are adding the exponents. Well, 5 to the power of 1/2 is just the square root of 5. So this is the final answer. Section 1, number 6. We have a geometric sequence, and we need to find the first term, a sub 1, and the common ratio, r. So let's first of all express all these terms in terms of the first term, a sub 1. A sub 2 is a sub 1 times the common ratio, r. A sub 3 is a sub 2 times the common ratio, r. Based on this pattern, a sub 4 must be a sub 1 times r cubed. So the first equation becomes a sub 1 plus a sub 1r plus a sub 1r squared equals 14. And the second equation becomes a sub 1r plus a sub 1r squared plus a sub 1r cubed equals minus 42. Now from the left-hand side of the second equation, let's factor out r. Notice that this expression inside the brackets is identical to the left-hand side of the first equation. So this is 14. So the common ratio r is -3. And let's substitute this value of r into the first equation to obtain the value of a sub 1. So the first term is 2, and this is the answer. Section 1, number 7. In this question we have 3 vectors, vector A, vector B, and vector C. And we are told that the magnitude of vector C is 3. Vector C is perpendicular to both vector A and vector B. And we need to find the values of x, y, and z. When 2 vectors are perpendicular to each other, the dot product of the 2 vectors must be equal to 0. Vector A dot vector C is 0, and likewise, vector B dot vector C is 0. This expression means 1 times x plus 0 times y, which is 0, and minus 1 times z. X minus z equals 0. And similarly, minus 2 times x, 2 times y, and 1 times z. Now, from this equation, we know that x and z are equal to each other, so we can replace z with x. So y is 1/2 times x. So y is 1/2x and z is x. Next, let's use this information. The magnitude of vector c can be calculated by the square root of x squared plus y squared plus z squared. Now, y is 1/2 x, 1/4 times x squared, and z is just x, so x squared. And since the magnitude of vector c is 3, this is equal to 3. So x is 3 times 2/3, which is 2. Therefore, y is 1/2 times 2, which is 1, and of course z is the same as x, so 2. And this is the final answer. Section 1, number 8. In this question, we have a triangle ABC, and M is the midpoint of BC, and we need to find the value of cosine ABC and the length AM. Let us first of all use the cosine rule. Cosine ABC is 6 squared plus 8 squared minus 4 squared, 2 times 6 times 8. So, cosine ABC is 7/8. Next, using the triangle ABM, we can calculate the length AM using the cosine rule once again. From the previous part, we know that cosine ABC is 7/8. And this is the final answer. Section 1, number 9. In this question, we have a quadratic function, f of x, and a tangent to the parabola at 0, 2. And we need to find the equation of the tangent, and then the area bounded by the curve, the tangent, and the x-axis. So let's find the equation of the tangent first. Differentiate f of x. F dash of x is minus 2x plus 1. At x equals 0, f dash of 0 is 1. So 1 is the slope of the tangent. Because the tangent goes through the point 0, 2, we know that the y-intercept is 2. So the equation of the tangent is y equals x plus 2. Next, before we attempt to calculate the area, let's try to visualize what is happening in this question by drawing the graph of f of x. So where exactly is the area bounded by the curve, the tangent, and the x-axis? It's really hard to see because of my poor drawing, but the area should be right here. The red area is basically this triangle minus this area under the curve. So let's calculate the area of this triangle. The x-coordinate of this intersection here must be minus 2, 0. The y-intercept here is 0, 2. So the length here is 2, and the length here is also 2. So 1/2 times 2 times 2, which is 2. And let's calculate this area under the curve. So this area is between minus 1 and 0. So this area in green is 7/6. So 2 minus 7/6 is 5/6. So the final answer is 5/6. In section 2, number 1, we need to find the radius of the circumscribed circle of triangle ADC, which is this triangle here, ADC. A circumscribed circle means that vertices of this triangle are on the circumference of the circle, like this. Since the angle ACD is 90 degrees, we know that AD is the diameter of this circle. Now, there's one formula that you should know. This is basically the sine rule, but when the triangle you're dealing with is circumscribed inside a circle, then this is equal to 2 times the radius r. So 2r is AD. This angle here is 30 degrees. So DC over sine 30 degrees is AD. So the radius is 1. In the second question, we need to find the radius of the circumscribed circle of triangle ABC, which is this triangle here, ABC. So once again, we have a triangle inside a circle, and we know that AC and BC are equal in length. Let's find the length of AC and BC using the triangle ACD. From the previous question, we know that AD is 2 and CD is 1, and this is 90 degrees, 60 degrees, and 30 degrees. So using the Pythagorean theorem, 2 squared is 1 squared plus AC squared. So AC squared is 3, so AC is root 3. So we can use the Pythagorean theorem once again to find the value of AB. AB squared is root 3 squared plus root 3 squared. which is 6. So AB is root 6. Therefore, the radius is 1/2 of root 6. In question 3, we need to find the radius of the inscribed circle of triangle ABC. So the inscribed circle of ABC is the circle that sits here inside the triangle. So let's call these points X, Y, and Z. And because AX and AY are tangents to this circle from a common point, we know that AX is AY. And from the previous question, we know that AX is 1/2 of root 6. So AY is also root 6 over 2. So this means CY here is AC minus AY, and AC is root 3, and AY is root 6 over 2. And because AC and BC are tangents to this circle, we know that this angle here is 90 degrees, and so are these two angles. And we also know that CY is equal to CZ. Therefore, we are dealing with a square. So CY is the radius R. So the radius R is root 3 minus root 6 over 2, which is 2 root 3 minus root 6. Next, in question 4, we need to find the length of DH. So first of all, let's calculate BD. BD is BC minus CD, which is root 3 minus 1. And next, we know that the triangle ABC is an isosceles triangle, meaning that these two angles are both 45 degrees. Now, because the angle BHD is 90 degrees, we also know that this angle here is 45 degrees as well. So we have another isosceles triangle. So we can find DH using sine rule. DH over sine 45 degrees is BD over sine 90 degrees. So DH is root 6 minus root 2 over 2. In question 5, we need to find the value of sine DAH. So in this question, we can use sine rule once again. Sine DAH over DH is sine AHD over AD. Now, the angle AHD is 90 degrees, and sine 90 degrees is 1, and AD is 2. And we know from the previous question that DH is root 6 minus root 2 over 2. So, sine DAH is root 6 minus root 2 over 4. And in question 6, we need to find cosine DAH. Now, let's first of all find AH. AH is AB minus BH. And we know that BH equals DH. So we are basically calculating AH minus DH, which is root 6 minus root 2 over 2. So AH is root 6 plus root 2 over 2. And next, recall that cosine theta is the same as sine 90 degrees minus theta. Therefore, cosine DAH is sine 90 degrees minus angle DAH. And 90 degrees minus DAH is just angle HDA. So we basically have to find sine HDA, which is this angle right here. So using the sine rule, sine HDA over AH is sine AHD over AD. Sine AHD is sine 90 degrees, which is 1, and AD is 2, and AH is root 6 plus root 2 over 2. So sine HDA is root 6 plus root 2 over 4. So cosine DAH is root 6 plus root 2 over 4. Section 3. In this question, we need to find the equation that corresponds to each of these graphs. So first, number 1 seems to be this straight line here. So number 1 is a straight line, and it has a positive slope, and it goes through the point 2, 0, and it has a negative y-intercept. So let's see. So 1 is a straight line, 2 is a straight line, 5 is a straight line, 9 is a straight line, 12 is a straight line, 14 is a straight line. 1 has a negative slope, 2 has a positive slope, 5 has a positive slope, 9 has a positive slope, 12 has a positive slope, and 14 has a negative slope. So let's try substituting these values into these equations. So let's start with number 2. 8 minus 0 minus 4. Wrong. Number 5. 2 minus 0 plus 6. Wrong. 9. 4 minus 0 minus 4. Correct. So number 1 must be 9. So next 2 is this straight line, and it has a positive slope, and it goes through the point 0, 2. The y-intercept is, of course, positive. So let's see. 1, 2, 5, 12, and 14. 1 has a negative slope, 14 has a negative slope. So let's substitute these values. Let's start with number 2. Wrong. Number 5. Correct. So this is number 5. Number 3 is a parabola, and it's concave up, and it goes through the point 0, 2, and the axis of symmetry, a positive number, and it has no real roots. So let's see. 4 is a parabola, 6 is a parabola, 8 is a parabola, 10 is a parabola, 13 is a parabola, and 15 is a parabola. And 4 is concave up, 6 is down, 8 is up, 10 is down, 13 is up, 15 is down. So let's substitute these values into number 4. 0 minus 60 plus 0 plus 60. So 4 satisfies this condition. Let's check number 8. 0 minus 60 plus 0 minus 60. Wrong. 13. 0 minus 60 plus 0 plus 60. So it's either 4 or 13. So let's check the axis of symmetry. So the x-coordinate of the vertex can be obtained with this formula, minus b over 2a. So in this case, the x-coordinate of the vertex is minus 8 over 30 over 2 times 1 over 6, which is a negative value, so the answer must be 13. And I guess we can also get rid of 4. Next, number 4 is another parabola, and it's concave down, and it goes through the point 2, 0, and the axis of symmetry is positive, and it has one real root. So 6 is a parabola, 8 is a parabola, 10 is a parabola, and 15 is a parabola. And 6 is negative, 8 is positive, 10 is negative, and 15 is negative. And let's substitute these values. Let's start with 6. Wrong. 10. Wrong, so it must be 15. And finally, number 5 is a circle, and it is in the first quadrant. And the radius seems to be 2. The coordinates of the center, 2, 2. So let's see. 3 seems to be a circle, 7 seems to be a circle, 11 looks like a circle, but the coefficient of y squared cannot be negative. So it's either 3 or 7. So we have plus 4 here. If we had another plus 4, then we could factorize these two parts as follows. But then, because we added 4 to the left-hand side, we also need to add 4 to the right-hand side. This is 2 squared. So the center of this circle is minus 2, and the radius is 2. So the answer must be 7. And this is the end of this exam paper.